everyone. This is the last question in the series of the various MMD questions, type of MMD questions I picked up. And this is about the triangular bulkhead with apex downward. A vertical bulkhead is in the form of a triangle apex downwards. The bulkhead is 9 meters broad at the top and 12 meters deep. So this 9 meter is the base of the triangle and depth is 12 meters. Tank contains seawater to a sounding of 8 meters. So here is very careful, because when we are taking the centroid and the moment of inertia about water surface, we can see that the tank is not full, is partly full, because the height of the bulkhead is 12 meters. 12 meters is the height of the bulkhead and sounding is only 8 meters. Find the thrust on the bulkhead and the position of center of pressure with reference to the bottom of the tank. So in this question, center of pressure and the thrust, we are only interested in the area of the bulkhead which is immersed in the water, which is below the water level. So the total area of the bulkhead is of no consequence, only the area which is below the water level. So this is a diagram. This is 9 meter broad base of the triangle and the depth is 12 meters. This is WS is marking the water surface, and from WS to the bottom of the tank is the sounding 8 meters. From water level to the bottom of the tank, that is the sounding 8 meters. G is the centroid of the triangular portion which is below the water level. Okay, and GG is the axis which is passing through the centroid of the portion which is below water level. What is the depth of the centroid from water surface? So we have this triangle WS, the inverted triangle with the base is WS. So we are talking about the depth of this centroid from the WS. It's always from the base of the triangle, the depth of the centroid is 1/3 of the height. The height of the triangle is the sounding, which is 8 meters, and 8 by 3 is 1/3 of the height. 8 by 3 meter is the depth of the centroid from the base, which is the water surface. Base is the water surface. And below that, below the centroid G, there is the center of pressure that we have to find. So I need to know the area of the bulkhead which is immersed in the water. That means from WS, this WS is the water level. Below this WS line, this is the area. So for this, I need to know the side WS, which is the base, the top portion of the triangle, WS. So by similar triangles, you see the big triangle, the base is 9 meter, height is 12 meter. And by similar triangle theory, we see that 9 upon 12, the base upon the height of the big triangle, should be equal to the small triangle which is formed by the water level. So base will be x, that WS that is x, and the height is 8 meters because of similar triangles. So 9 upon 12 is equal to x upon 8, and we get x is equal to 6 meter. So this is the top water level surface, which is 6 meters is the base of this triangle. So what is the immersed area of the triangle? Half base we just found 6 meter, half base into height is the sounding 8. So half into 6 into 8, and you get 24 square meter is the area of the immersed surface. And what is the depth of the centroid of this bulkhead below the water surface? That is 8 by 3 meters from water surface. Okay, one third of the base height, one third of the height from the base. Height is 8 meters, so 8 by 3 meters from the water surface. What will be the moment of inertia of this immersed surface about water surface, about water line? Okay, we find what is the moment of inertia about the centroidal axis passing through centroid, plus area of the immersed surface multiplied by d square, where d is the depth of the centroid below the water surface. So moment of inertia of a triangle about the axis passing through its centroid is b d cube upon 36. B is the base of the triangle, d is the depth of the triangle, and remember this is the depth which is immersed, and the base is which is immersed in the water, not the complete triangle. Divide by 36. Then again the area which is immersed in the water, and d is the depth of this centroid of the immersed surface. So b will be 6 meter in our case, and d will be 8. 6 meter is the base of the top portion of the triangle which is immersed in the water. Then 8 is the sounding, so that is the depth. 6 into 8 cube upon 36. And we simplified this, we get to 56 meter is to power 4. That is the IWS. Center of pressure from water surface below the water surface is again moment of inertia about water surface upon area, immersed area into depth of the centroid below the water surface. So IWS we found 56 here, and immersed area of the bulkhead is 24 square meter. Depth of the centroid below the water surface is 8 by 3. So just simplify this thing and we get 4 meters. Center of pressure from water surface is 4 meters, and the sounding is 8 meters. So center of pressure from bottom of the bulkhead will be 8 minus 4 is equal to 4 meters. And the thrust again, pressure into total area, pressure at the centroid, density 1.025 multiplied by depth of the centroid from water surface, which is 8 by 3. Total area which is immersed below the water surface is 24, and we get thrust 65.6 tons. So why I picked up this question is just to be very careful that it's a simple triangular bulkhead, but it is not fully immersed. So we have to focus on the part of the bulkhead which is below the water level. Area of the bulkhead which is below the water level. Then centroid is also of the immersed surface area. We have to find the centroid of the immersed surface area and what is its distance from the water surface.